Welcome back. In this session we are going to see how we can use statistical analysis to find out if an information is relevant or interesting in a text. So what does it mean exactly? We know that we can apply queries to a corpus, even complicated regular grammars, and then we can locate words or terms, lexical fields, themes, concepts, expressions, and build the corresponding concordances. Now, the theme that we have located, is it interesting or not? For example, does the theme love, for example, interesting in a novel? Is it interesting to look for immigration in a political debate? Is Middle East important in a certain newspaper in a certain date? Is there a problem about left front axle in accident insurance reports? Or can we find out that there is a problem with the antenna of a smartphone by looking at product reviews? So the first idea, of course, is to study the frequency of this theme, concept, lexical field, or expression. The basic idea would be that if a text contains many occurrences of the term, of the concept, then it must be relevant and interesting to the text. However, if we look up the word the in any English text, we are going to see that it's very, very frequent, and that does not mean that it's specifically relevant to a given novel. So the frequency by itself is not really interesting. So for example, in the Portrait of a Lady, if I look for the word the, I'm going to get 8,066 occurrences. That doesn't mean that the word the is interesting to study in this novel. What is more important is not exactly the frequency by itself, but the difference between what we expect and what we find. Of course, we expect any English text to contain many occurrences of the word the. We find out that there are indeed lots of occurrences of the word the in a novel. There is no surprise. It's not interesting. However, let's say we expect to find absolutely zero occurrence of a concept, let's say the term COVID in newspaper from the 20th century. But if we were to find even only one occurrence, that would be very, very interesting. So what we want is to find out, to measure the difference between the expectation and what we observe. So expected and observed frequencies. So to simplify, maybe let's say we have a text or a corpus that contains 100 pages. If we look for the word the, and we find out that the resulting concordance contains 1,000 occurrences. We have 1,000 occurrences of the word the in a 100-page text. So we expect to find approximately 10 occurrences per page. So here are the pages, page 1, page 2, page 3, page 4, etc., all the way to page 100. And this is the expected frequency, which is basically the average, the mean. So it's 10. So we expect the frequency of the word the to be around 10. And this is the observed frequency in green, the expected frequency in red. And this is basically what we're going to get, right? On the other hand, let's say we are looking for the word killed in the same novel, and let's say that we find also that there are also 1,000 occurrences of this word. However, so the expected frequency is also 10. However, instead of having always or around 10 occurrences of kill every page, we find out that we have 0 occurrences of the word killed basically everywhere, except in 2 parts, in 2 particular locations in the novel. So now we think, but this is very interesting. It means that maybe in chapter 7 and in chapter 19, somebody was killed. So we have to contrast this graph with this graph. This graph not interesting, this graph very interesting. So now we need to have some kind of objective measurement to see like what's between these two extreme cases. So for example, in the blue here, we have the same, right? We have an expected frequency, we have observed frequency, but is it interesting or not? Are we like in the same case as here, or are we in the same case as here? So in order to find like an objective criterion to see if something is interesting or not, we use what we call the Gauss normal distribution. And this Gauss normal distribution is basically used in basically all the sciences. So for example, let's check out the newborn baby's weight in a population. So we are going to find out that most babies, they weigh a certain weight, let's say here. And there are lots of babies in a country that have this weight. There are less babies that are maybe 1 pound heavier, or less babies that are 2 pounds heavier, etc., etc. And maybe there are just maybe one baby per year who has a weight that's, I don't know, like 15 pounds. And on the other hand, we have lots of babies with this average weight, but we have less babies with this weight, less baby with this weight, etc. We have the premature babies around here, and maybe once a year we have a baby that, you know, that weigh I don't know, half a pound, and that can survive. So the mean is right here, and we have a symmetrical curve which is called the Gauss normal distribution. It's the same thing for life expectancy. Let's say life expectancy for men could be, I don't know, 76 years. So most men, they live around 76 years, and then we have some 80-year-old men, and then 90-year-old men. We have very, very few 100-year-old men, but maybe we have one 110-year-old man in the population. And in the same way, there are people who die before 76, men who die before 76. So if we look at the population, which is basically the area below this curve, we find out that if we look at the mean and the standard deviation, if we have the 68%, let's say 78% of the population, which is between the mean minus a standard deviation and the mean plus the standard deviation. If we look at this area, so we have 95% of the population which is measured between the mean minus 2 standard deviations and the mean plus 2 standard deviations. So this is exactly the criterion that we are going to use. It's used basically in all sciences. We are going to use it to consider if an information is interesting, exceptional or not. So we're going to say that if the frequency of the word or the concept is here, so it occurs extremely frequently in a certain part, in a certain location, in a certain area of text, which means the mean, the expected frequency plus 2 standard deviations. So if it occurs here, this is exceptional. It should only happen in 2.5% of the cases. So we're going to say, well, this information is very interesting. And on the other hand, if it occurs it does not occur, or it occurs its frequency is very, very low, but exceptionally low in a certain area of the text, we're going to say also that it's exceptional. It's interesting. So the standard score here is going to evaluate the distance between a given value and the mean in the population. So if we are above 2 standard scores, 2 standard deviations, so the standard score is above 2, then the measure is abnormally high. It's very interesting. And if it's below -2, then the frequency is abnormally low. It's very interesting. And between -2 and +2, the value is located within the normal range. So it's not surprising, not interesting. So So if we look at the death lexical field that we for which we wrote a grammar before, in the portrait of the lady, we're going to find out that here, you see, at the end of the text, there are lots of occurrences of this concept, this theme. So, but in an exceptional way. You see, the standard score is above 2. And the equivalent for French, like there is a novel, La Femme de 30 ans. If we look for the concept, for the theme, la mort, death in French, we're going to see that we have 2 peaks, one in part 7, one in part 19, which correspond exactly to what happens basically in the story. So here what we did was we applied a regular grammar that is capable of representing, of finding in a text complex linguistic units, not only word forms, but terms, concepts, expressions, lexical fields, and we can apply them, we can apply the corresponding grammar to a text to find occurrences, and then we are going to perform some statistical analysis, not on word forms, but on complex linguistic units. And the standard score is a good measurement to see if a concept is interesting in a corpus or not.